All right. Hello, everybody. Today, we are going to be talking about a problem from the January 11th comprehensive exam. And we're actually going to be going over question 1, which deals with Taylor series and approximating functions with their Taylor series expansion. So this is from Calc 2, the end of Calc 2. So we're stepping back a little bit from yesterday, which was Calc 3. I'm actually super interested in Taylor series, so this should be a fun one. And the question reads as follows. Let f of x be e to the x plus e to the negative x, the quantity over 2. Now, this is a really special function because if you don't recognize this, this is actually the hyperbolic cosine or cosh x. And we're actually not even going to need that information for this problem. But if you do recognize that, bonus points for you. And we are trying to find a parabola g of x, which is ax squared plus bx plus c, which gives a good approximation for f of x near x equals 0, in the sense that g of 0 is equal to f of 0, g prime of 0 is equal to f prime of 0, and g double prime of 0 is equal to f double prime of 0. So these are all very good hints that we are actually going to be working with a Taylor series, right? Because we know that Taylor series are used to approximate functions. So anytime you see find an approximation and it's a polynomial, right? Because a parabola is a polynomial, this is our hint that this is going to be Taylor series. We also know that part of the Taylor series process is by setting the respective derivatives equal to each other. In fact, right, so I'm going to write Taylor series down right here. And in fact, we can use, right, the formula for a Taylor series. So to find the second degree approximation, right, that is going to be equal to the sum. And k is going to always start at 0, right? Because the 0th derivative is just the original function. And go to 2 of the kth derivative evaluated at 0 here, right? Because we're trying to approximate it around x equals 0. Over k factorial times x minus 0 to the k, or just x to the k. Awesome. So if we were to expand that all out, all that would be is f of 0, right, plus f prime of 0 x, right, because 1 factorial is just 1. When we divide it by 1, nothing's really going to happen. And then plus f double prime of 0 over 2 x minus 0 squared. So really all we need to do is find f of 0, right, f prime of 0, and f double prime of 0. And then we can just go ahead and plug it into this formula. All right, so f of 0 is easy, right? We just plug it 0 into the original function. The original function, right, is going to be e to the x plus e to the negative x over 2. So that's just going to be equal to e to the 0th is what? Well, that's just 1, right? Plus e to the negative 0 is just the same thing, right? 1 over 2, which we clearly see is 1. So f of 0 is just 1. Okay, that's good, right? Now let's take a look at f prime of 0. Well, first we have to differentiate, right? And if we know that it's the hyperbolic cosine, we can just say, okay, well, the derivative is hyperbolic sine, right? If we didn't know that, we would just take the derivative of these two respective functions and keep that 1/2 coefficient, right? So that would actually turn into, let's do that out here. E to the x is going to stay the same, right? Minus e to the negative x, right? Because of the chain rule over 2, we keep that evaluated at x equals 0. That is going to give us 1 minus 1 over 2, or 0 over 2. So f prime of 0 is just 0. And with the hyperbolic cosine, you'll notice that every even term of the Taylor series is going to disappear. Or sorry, every odd term, right? Because we technically count the first one as the 0th term. And that is very similar for regular cosine as well. So that's something to notice. Now, to calculate the second derivative, we just take the derivative again, right? And we're going to end back up with our original function, right? Because e to the x isn't going to change, but that negative is going to come down once more, and it's going to give us this, right? Which is our original function. Okay. And when we calculate that, that's just going to be 1 again. So we have found all 3 of the coefficients that we need, right? And then we can just go ahead and plug it into this Taylor series approximation right here. All right. So f prime of 0 is just 1. That's going to be plus 0x, right? We don't necessarily need to write it, and I'll simplify it down at the end, but plus 1 over 2, right? Don't forget this term here. That's where that 2 is coming from, x squared. So again, to simplify that, we have p2 of x is just going to be equal to 1 plus 1/2 x squared. And that is the second degree Taylor series approximation for this function here. And you'll notice that if we graph these two functions, which I'll do in a second, they will be very similar to one another. So let me go ahead and graph that, and I'll be right back. All right, so I have the two functions graphed up. This first one in red, that is going to be our original function, the hyperbolic cosine, otherwise known as e to the x plus e to the negative x over 2. And then this blue function here, right, this is going to be our parabola, our Taylor series approximation. As you can see, right, as we get farther and farther away from 0, it's not a very good approximation, right, around here. However, as we get closer and closer to 0, we see that it is quite a good approximation. If we were to continue to add terms, the approximation would be even better. But as we can see, for values of x that are very small, this is already going to be quite a good approximation in the sense that we have to zoom in for a while before we even see, right, any differences between the two functions. So that is how to approximate a function using a parabola around a given point.